through some of the basics right here so that you can see the diagnostics that we're talking about. I don't want to go too far into the technical side of this stuff, but with the diagnostics built in, our technicians can determine if the power to the building is in sync with the kiln, the way we built it, if the wiring to the kiln is adequate. If you have a relay, one of the little switching components that's burned out, we can tell you if you have one of those that's failed, and if so, where in the kiln it's burned out. If you have an element that's burned out or broken because it got some contamination on it and failed, we can tell you which element is gone. And given any of those things that might be slightly out of specification, we can tell you how hot the kiln will fire. Probably not as critical for you folks because you're doing low fire, but once we get into high fire temperatures, it's really important to get every single watt that we were planning on to heat up the chamber actually in the chamber. So let's take a minute here and I'll run through the two diagnostic options you have. And a kiln repair person would have to do this with a handheld meter on a red control box, but you guys can actually do this on this green controller pretty simply. I don't know if you guys can see here. You might want to just come around for it. I'll try to get this out here where everybody can take a look at it. From an idle state, what we're going to do is pop over in these menus. This is the setup menu where there's about 10 options under here if I pressed enter. But by pressing the menu button again, I move over to another column that's the diagnostic menu. I'm going to press enter here to see what options I have. This one is just when the last error occurred. If in fact you had an error condition, that would tell us what's going on there. This one is very handy. It gives us 2 of the 5 pieces of data that we absolutely have to do these calculations. And it's going to tell us both our static voltage, just a no load voltage like we have at idle, and then it will also tell us the voltage. It'll turn all the elements on and tell us the voltage drop or any change in voltage as a result of turning all the elements on. So the first one is right here, and it's called the no load voltage, and it's perfect. It's bopping back and forth between 241 and 242 volts. You match that up with what's on the side on the nameplate of the kiln, and this one should be a 240 volt kiln. It is. Yay, Colleen, we got the right one. Okay, and then at this point, of course, there's no power going through the kiln or to the heating elements, but as soon as I press enter this next time, it will turn all the elements on, give us a number, and turn off pretty quickly. So you have to be ready for the second one. And it's going to say full load voltage. You'll hear a click, and it drops to 231, 232, which is pretty normal given that there's the click to turn off. So we turn it off right away so there's no potential that the thing takes off. And you look at this extension cord that we've got running, clearly that's not the prescribed method, and an 8-volt drop is really not bad at all given a 50-foot extension cord. Okay, but you guys are direct wiring, you won't see a voltage drop like that. On a 240 volt kiln, we don't want to go any lower than 228. As a practical matter, for what you're doing, you could probably fire on 208 and you'd never know the difference to low fire temperatures. But again, high fire, we got to have every possible volt. So that gives us 2 data points, the no load voltage and the full load voltage, very important. And with just a couple button presses, we were able to get that information. Completely helpful to our technicians. Okay, now let's pop in and do that same thing, but I'm going to pop down, instead of voltage, I'm going to go one more and do an amperage check. And this is going to turn on one section at a time and watch the actual current flowing through there. Now that we know what the voltage is, we have a reference point for an amperage reading, and then we can calculate the wattage. So what this does is it pops through amps 1, it turns on the top section and tells us 18 amps. Then it's going to automatically go down to the second section, and it's 15 amps. And then it's going to click one more time and go to the third section, and it should be 18, should be symmetrical. And the top and the bottom of the kiln are a little bit hotter than the middle by design, as to allow for the heat flows through the lid and the slab. So that one, again, it's always nice to see them come right out of the factory the way they're supposed to be. That's exactly what we'd like to see. And if we were to multiply out, if we were to add up 18, 15, and 18, what's that, 32, 37, 47 amps? Okay, 47 times 240 is going to be really close to, it says right on the side of this thing, 48 amps. So within the rounding or the error possible in the built-in diagnostics, we're right on target. As a kiln ages, the heating elements increase in resistance, which means the amperage will drop and the wattage drops. So as a kiln gets older, it produces less and less heat. That's all you need to be aware of. And at some point, you won't be able to produce enough heat to reach cone 06. As a practical matter, I can tell you that you could probably get thousands of firings to cone 06 off a set of elements. And multiple thousands might be pushing it a bit. 1,000 to 1,500 firings if everything's copacetic and there's no contamination. But that's a lot of firings. I want to go over just a couple other things to pound on the thermocouples one last time. Sometimes people ask us, well, Jim, that's kind of a, now we're doing maintenance on our thermocouples. Why do I have to change a thermocouple? Why can't you build a kiln with a better thermocouple in it? And I love that question because we can. We can build a kiln with a thermocouple that you'll never have to replace from thermal cycling, from heating and cooling. And it's, we call it a Type S thermocouple. It's good to 2,800 degrees Fahrenheit. It's the one that's pictured in the top of that photograph right there. But you notice there's a ceramic tube around it. And what did I say about hitting thermocouples with shelves? If your staff, I know none of you would ever do this, but if anyone, and wait a minute, we've got a staff member here, I got to be careful. If by chance some staff member wasn't really on top of their game and they happen to hit that with a shelf, they're $250 a piece. Generally speaking, people say, Jim, that's all right, I'll keep buying the $13 one. But it's up to you. They don't flake, they're very responsive, they're lovely. You can always upgrade to them in the future if you have a green controller. We generally don't recommend them in any kind of a public setting or a commercial setting, and they're not really necessary at your temperatures. You should be getting pretty good life out of your thermocouples. For high fire artists, cone 6, cone 10, we recommend them routinely. People still balk at them. Even though they're only going to get 75 firings out of a thermocouple, they still don't want to put these in. They will drift towards an overfire. Keep an eye on them. Scaling's normal. Use the toothbrush. I just have to put it in because it was 3 hours ago when I told you that for the first time, and I've told you a lot of stuff. Let's take a look at how you change one. But before I get in here, what should I do? Safety first. Cut the power to the kiln. Okay. There we go. So I'm going to take out these last 2 screws. You'll have to take 6 of them out. But this is something that we expect any of you to be able to do as owners of these little beauties. It's a 2-minute job, and it's well worth keeping that signal to the controller conditioned and working nicely. Okay, so don't freak out if you're squeamish over the sight of blood. Some people get squeamish over the sight of wires. Thank you, Bruce. So it's twice as bad as you think it is because there's a reflective surface here. Or it's half as bad as you think it is because there's a reflective surface here. Really, there's only a couple wires, but it looks like a mess because you got all the mirrors in there. This is what we call the thermocouple terminal block. It just attaches to the kiln in 2 spots. And then we've got the thermocouple right in here in the middle of it. And these wires will never have to be changed or disconnected. So don't even think about disconnecting them. You can do this whole thing without taking this yellow wire off. One thing that is kind of weird about thermocouples that I want to draw your attention to is that they're different than car batteries. For anybody who's ever used jumper cables on a car battery, what color is positive on the car battery? Any? You've never done it? Okay, so if the plus sign is the positive and it's red, and the thermocouples are backwards. So what happens is, if I don't mention this, the people who are inclined to start moving wires, they open the thing up and they go, well, Jim and his crew, they're a bunch of dorks. They got it backwards. Everybody knows red is positive. So they reverse this and they turn our kiln into a refrigerator. Well, okay, they don't really, but the kiln gets a backward signal. And so it has an error condition for that, and it says, I'm trying to heat up and the temperature's going down. We must have a reversed thermocouple. But then they go a step further and they say, Jim and his crew must be really dorky. They did it not only once, but they did it twice. They did it over here. So we're going to correct it over here. Now they've created a vicious situation where the kiln will overfire by about 300 to 400 degrees. So don't move these wires. That's the Reader's Digest version, all right? I had to digress. Okay, so all of that having been said, now it's just these two screws. And these are on here, these heat shields are on in a very loose fashion by design. We don't want any heat transfer into this piece of metal if we can help it, because that just puts heat into the box. So it's a little bit, you know, it's a little delicate, but you get the point. It comes off here. So once I get these two screws loosened, I can take the entire thermocouple out from the kiln, okay? So that's easy. Then at this point, all you've got to do to change the thermocouple is loosen the two center screws, just a little half turn each. And then this thing will come right out. And if you notice, one of the two leads is color coded. Okay, so we actually took a little felt tip marker and marked one of them red. Red is negative. It's going to match up with the red wire. Okay? So I want to make sure everybody can see that. So then you take this old one and you throw it away, and you take the new one, and we probably put a little rubber band on there to keep these from flying off. Take the rubber band off, or if you just fire it once, it'll take care of itself. Leave these, try to hold these insulators down. It's not imperative, but then just line up the red lead with the red wire going from the inside, and push it out until these are flush with the end of this little brass block. Okay? Then that's the right depth. It'll get it set for the right insertion distance in the kiln. Tighten these up, and you don't have to be Hercules on these things. Just snug is good enough. You don't have to really crank down on them. And that's all there is to it. Reverse the steps, put this back in here. It can't get much easier. We even give you a spare thermocouple inside a new kiln. So when you use the spare, order another spare. All right? Mike, do you guys have those readily available for them? Or do they have to source them on their own? Okay. Well, okay. Well, it's just something that, you know, when you notice some drift, so then you've got to attach these last two screws. When you notice some drift with your cones, you're going to want to just replace it. Or buy the $250 one that never drifts. Yeah, any of the standard ceramic distributors around the industry have them. Okay? Part number 1515. There you go. Again, don't over tighten these screws. They're sheet metal screws and they can strip out. So that's that. We talked about heating elements, and when they get to about 5 or 10% increase in resistance, generally you're going to have to replace them. I just wanted to show you a couple of the steps here because we've got our hands on the thing. But we do have a DVD of some clips for replacing bricks, replacing elements, which are really detailed. And they, you know, little movie magic takes a 15-minute job down to about 2. And so I'd recommend looking at our DVD. They're also on YouTube. They're on our website. Many of you have probably seen them. But because we've got cameras rolling right here, we can take a look at a few of the key areas. So right here, if you do have to replace a single element, for example, of course you've unplugged the kiln, safety first. And these are where we call these white wires feeder wires. This is the voltage that's going to be supplied to an element. Each element wraps around the kiln twice. So it starts here, wraps around, steps down a couple inches, wraps around again, and then comes out here. And when you're replacing the elements, you actually have to take some wire cutters and cut this off. This barrel connector has to be cut off right here. And sometimes it's kind of tricky to get in there, but that's how you've got to scooch this little guy forward and get in behind that barrel connector and cut that off. And cut this off. You'll take the rest of the barrel cutter and take it off, or the wire cutter, and take that barrel off of the feeder wire, and then strip back some of the insulation and get ready to reinsert it into the new barrel cutter.